Good afternoon, welcome. And this is the RPKI track. We are lucky today. We have two co-moderators. We have Doug Montgomery and Sandy Murphy. A lot of you know them. They really don't require introduction. So let me try. They are very active in this community. They are very involved in NANOG, IETF, and the RIR communities. And Doug works for the National Institute of Standards and Technologies. He has been there for 30 years, and he leads the research and standardization effort in a wide spectrum of things, and which also includes the routing security and IP security. And Sandy works for Parsons. She also co-chairs the Secure Interdomain Routing Working Group in IETF. She's also she has 20 years experience in working in routing security. So thank you. We are happy to have them. I'm going to turn the track over to them.
So I am going to give a short introduction, hopefully summarized and clear, of what the RPKI is. And then we're going to have a sequence of topics of the services and the implementation and the deployment of RPKI. So you probably are all aware, here are some examples of some of the more recent incidents that have involved BGP origins that were false. So these were prefix hijacks. The first one was a brand new thing that was reported at the last RIPE of someone who misoriginated over a peering connection at an IXP in the RIPE region for the specific purpose of misdirecting mail to Yahoo, because there's a nice fertile field there to deal with. The second on there is one of the accidental things that can happen so often. We've had examples of T-Mobile, for example, on the NANOG list talking about, could somebody please help me here? The third one is there's another new reason for doing prefix hijacks. This one allows you to break up your HTTPS sessions. And the last one was kind of misoriginating Bitcoin so that you could mine the virtual money. So that was a brand new motivation. So preventing prefix hijacks means finding out who is the legitimate originator of a prefix. And the idea is that the legitimate holder of the prefix is the one who should say who's authorized to originate it. So in the IETF for many years now, the IETF, the RIRs, the router vendors, security people have been working on developing a system that would say who is the person with the right to use an address space. And each certificate in the RPKI certifies that you have the right to use that. With a certificate in hand, you can do a digitally signed route origin authorization, which says this AS is allowed to originate my prefix. So there's a lot of parts to this. We're going to be explaining. Oh, golly, okay. Thank you for that reminder. There we go. There are a lot of parts to this. We're going to be explaining the various parts that go along with the originating protections. So there's two sides of this. This is classic producer-consumer model. The first half is certification. You want to certify that you have the right to use an address block. You get the certificates, you sign the ROAs. If you're going to have customers, maybe you're producing certificates for them. When I'm talking to non-networking people, I say, think of this as signing the back of your credit card. For you guys, it's more like, think of registering the route object. The other side is the consumer side. It's the getting the origin validation information into the routers. This is like the merchants checking the back of the credit card, or like you doing prefix filters. So let's talk about the resource certificates themselves. It's all based on the allocation system. So there's trust anchors in each RIR, and for each allocation you receive a certificate. You digitally sign the ROAs using your certificate, and those certificates and the ROAs are all published in a repository. In the hosted model, the RIRs is doing this as a service for their members. They're doing the certificates. They're also hosting the repository. If you have customers and you want to generate certificates for them, then you use something called the delegated model, where you ask the RIR to give through the up-down protocol to let you operate independently, and then you operate your own repository. You generate your own certificates for your customers. So in one particular AS, when you're doing the origin validation, the idea is you gather all this information in from the global repositories. Right now, there's the 5 RIRs and a couple of other examples that are of people who are running in the delegated mode. You gather that in, you do all the crypto, you do all the certificates checking, you check the signatures on the ROAs, and you pass.
So let's go ahead and get started here. So here's the possible data flow for operations. So Sandy kind of gave you a little bit of an overview of how these sort of certificates all sort of work together. And it's all based off the address allocation hierarchies. So it makes a lot of sense that Aaron actually put also have to take hold your keys, your private keys. And from a security conscious perspective, that's something that a lot of people don't want us to do, or people don't want to have happen. But for a hosted model to work, we have to have your private keys to do these daily signatures that are taken care of. There's also another con as we go through this, is that there's a UI that you have to go through, and for each route you actually have to put in a new entry, and I'll go through that in a little bit. So now, with the RESTful interface, we make it a little bit easier to use if you have a large number of networks you want to do, because we have an API that you can use to go ahead and add these entries in. Now, one of the things I'll note is that we have a high security module that's been programmed that only you can make these entries within our system. Because Aaron, as you know, is just an address allocation agency. And one of the things that this does is it starts adding in some routing things that really you guys want to control. And what we don't want to do is make any changes on your behalf or as a mistake that affects your business. So we created this high security module in a way that only you can actually make changes into our system. And there's no way that Aaron's staff in any fashion can make any changes to the system. And the last type is delegated RPKI, which you run everything yourself. And you basically need to show us a little bit of information. It's a lot harder to set up, and you need to set up your own RPKI environment to happen. So let's go through this and show how this goes. So you go into Aaron Online. Anyone actually log into Aaron Online before? Anyone have an account here? All right, all right. For the rest of you, do you want an account? So if you have everything's cool. And once that's done, you're good. So now, one of the things I'll note with up-down is that you have to do all the ROA creation, you have to do all the updating on a regular basis. You need a set of the CA, you have to have a highly available repository. And that's one of the things that people don't realize, is that this repo, everybody has to get this information from you. So if you want your validated routes, you want your routes to be validated by others, this repo needs to be available. And of course, you have to create a CPS, a Certificate of Practices Statement, and which may involve some lawyer review. So updates within RPKI outside the ARIN region, the other regional registries, the 4 other regional registries are also available. We have delegated working for the public. Apparently APNIC does as well, and so does RIPE. There's major routing support, of which you're going to hear some from the vendors here pretty soon. There's public domain code support through Quagga and BIRD as well. Now here's some information I'm showing you in terms of, here's how long we've been out there. It's been out there for almost 4 years now. And you can see that we've been working on it, and we've done quite a bit of work on adding additional accoutrements to RPKI. But here's the interesting part. Here's our usage. Kind of a little bit on the low side. And one of the things I'll mention is that ARIN has has over 5,000 members within ARIN, of which could play in this space. Only 250 are doing so right now. And out of those 250 organizations, there's 370 ROAs, which cover 528 networks. So it's fairly small. And the last thing I'll note is up-down delegated, there's one organization that's actually saying, I'm going to do it, but never has. So there's really no one that has actually played with delegated yet within ARIN's region. So anyways, that's a short summary, what's going on. Hopefully it was very quick, but it's very simple. So if you want to play in the space, I showed you our production network. We also have an OT&E network, so you can go ahead and play in this on the side, and it doesn't involve any production stuff if you want to go ahead and do so. Please talk to me afterwards if you want to do that, and we can make that happen. Okay, thank you.
Okay. Start my own timer so I don't lose track. So Sandy talked about there being 2 sides to this set of technologies, right? A producer side that is allowing you to register and get res certs for your resources and create ROAs and publish them. And now we're going to transition and talk about the consumer side of this, right? The software and tools that will digest that data and eventually use it to implement route filtering in routers. So we mentioned the idea of these software tools called validating caches that exist out there, right? So the idea of the whole RPKI model is not that these certificates and X509 data makes it to routers. The model and the architecture has always been that you'll deploy within your network validating caches, right? And validating caches are tools that go out and synchronize the global repositories for RPKI objects, download those and maintain a locally synchronized cache of that data, perform all of the X509 validation it takes, right, to check the crypto properties and the authorization properties that are inherent in the model, and then to transfer to routers a highly distilled version of that, not X509 objects, but simple whitelist of tuples of prefix max length authorized origin AS. There's a few protocols involved in this space, so synchronizing the objects from the global repositories. Traditionally, the original model was using rsync, and it's the model that's still implemented out there, right? The rsync protocol to download the local caches from the global repositories. There's work going on in the IETF now to transition that to something called RRDP, the RPKI Retrieval Delta Protocol, which is real advantages there is that it's going to an HTTP technology, and it's moving for multiple reasons to a different model that sort of lends itself to the update cycles, right? Is rsync is well structured and optimized for certain scenarios, but it turns out what we're seeing so far in the RPKI is sort of very small updates. And so RRDP provides an HTTP-based protocol, one that can be run through CDNs to address some of the issues about availability, reliability, and responsiveness of the RPKI repositories. It's implemented in at least 2 of the validating caches and one of the RIR repositories that I know of. The second side of this is, so the RPKI caches download the data from the global repositories, do the X509 validation. The second side is feeding the distilled results, the ROA data, to routers. And that's done with something called the RPKI to router protocol. It's a simple protocol defined in CIDR that allows you to connect to a validating cache and download the full table, do incremental queries and updates for partial updates of the data, and to even allow the caches to signal you that since the last time you downloaded ROA data, something in the RPKI has changed, and you need to either add or withdraw data. So there's multiple open source implementations of validating caches. In the essence of time, this is the one piece of technology that we chose not to have the implementers come up. I'm not the implementer of any of these, but we decided to try to provide a brief summary of their relative features, right? So we have this taxonomy that looks at each of the RPKI validating cache implementations. There's one from the RIPE NCCC, sometimes called the RIPE Validator. Dragon Research Labs has another implementation, sometimes called RPKI.net, and BBN Technologies has an implementation called RIPSTER. They're all validating caches, right? So they all do the basic functions I talked to you about, right? Download the entire repositories, the global repositories, X509 validation, RPKI to routers. Some interesting differences we've talked about the up-down model and running in a delegated mode. The Dragon Research Lab validating cache can also act as a certificate authority and run the up-down protocol if you want to run in a delegated mode. We talked about the 2 protocols for doing the RPKI synchronization. So they all do rsync, the original method of doing this. Both the RIPE Validator and the Dragon Research Labs have running implementations of the new Delta protocol, the HTTP-based protocol. Oop. I'm running the clock, and I'm reminded that I'm over time. So they all do RPKI to router. Different management faces. Some have web interfaces, some just CLI kinds of interfaces. You can look at the distributions. We have a Java app, Python development C source, and all are supported in one way or the other. RIPE NCC through the full RIPE services interface. RPKI.net has a reasonably active and thriving sort of open source community, an email list, and there's the RIPSTER. So that's all we're going to say about that space. Shifting to the other side, the final side of the consumer model is looking at router implementations. And here, right, we've talked about that there's an interface that provides this highly distilled ROA information down to routers. Routers use this information to do filtering in various ways, and rather than me talk about that, the good news is that we have major router vendors who are shipping this code in commercial products, and we're going to let them talk about it. So first up is Greg Hankins of Nokia, who will tell us about their implementation.
Hi, I'll just tell you briefly about our implementation. So we've supported this for a couple of years, started shipping it 2 years ago. For those of you that don't know, and Mark kind of asked this question when we were getting up on stage, SROS originally started out as Temetra, then was acquired by Alcatel, merged with Alcatel and Lucent, and then now Nokia just acquired Alcatel-Lucent in January. So it's the same operating system, it's just undergone some ownership changes, but same name. Since then, we've had a couple enhancements, not much development though, to be honest. It's supported for V4 and V6. You can configure in-band or out-of-band communication with the server, and we've tested it with RPKI.net. We support these 3 standards. And also several platforms, the hardware-based platforms support it. Also our virtual router platforms support it. And it's integrated with our 5620 SAM, which is our management interface. But really it's accessible with any management that you want, CLI, SMP, or NetConf. So it's pretty flexible to integrate with anything that you have out there. Configuration is pretty simple. You have to configure the RPKI session. You can do that dynamically with the server that Doug was just talking about, or you can also create static entries if you'd like that are valid or invalid. And here's how you can show it. You see that the session is established, it's getting records, so that's good. And then you have to configure 3 things in BGP to actually make it use the information. First, you turn on origin validation and path selection. So if you don't do that, then it would get the information, but it wouldn't use it in the comparison. You can also configure if you want origin routes that are invalid to be discarded or to be used. So that's a personal choice, up to you. And then you just have to turn it on for V4 or V6 in the peer group. If you would like, you can also configure routing policies. Sorry, this is a little bit small, but there's basically a keyword called origin validation state, and it can be valid, not found, or valid, and you can do different things in a routing policy depending on which type it is. You can also show the database. So here's a show example. It shows you a dynamic entry that was learned from a server and a static entry that was configured. You can also do a summary to see how much stuff is in the database. And you also can show the route actually in BGP. It has an origin validation field in there in the show output that I've trimmed down, so this will be valid, not found, or invalid. And that's about it. It's pretty simple and straightforward to configure.
Craig Voljanik from UPMC. Does the product also, does this code work in VPRNs as well as the base context?
That is a good question, and I do not know the answer to that. Actually, I checked on that. No, this is only in the base router context. Okay, thanks.
Next up in our router implementations is John Scudder of Juniper.
All right, hi everybody. You get to hear the same thing again? Not quite. We have been doing RPKI for quite a few years now. I think the initial implementation took, like a month to do or something like that. It's really actually fairly straightforward once you get inside the router code. We are support 6810, 6811, and the latest version of the OV signaling draft, which is really just a way of saying you can pack your validation state into a community and send it around inside your AS. And it's anything that runs Junos is supported. This is a simple picture of how you can set up talking to your cache. Of course, you can, if you're a control freak, you can adjust any parameter that exists in RPKI router, but this is actually a fairly practical configuration in real life. Under normal circumstances, you probably don't need to go into those. There also is, and this is something that is not part of the standard, but may or may not be of interest to you, and you'll find it in the documentation, a static option, which lets you dummy up a static, locally configured RPKI or an object inside of the router. We basically implemented this for testing purposes before we had a validating cache to test against, but then, after we debated, should we just tear that out now that we have a validating cache to run with? We're like, oh no, maybe somebody will find something useful to use or abuse this for. So put your creativity to work. How do you use it? If you know how to use a Juniper router, this should all look extremely straightforward. If you don't, then, talk to somebody and learn. Basically, when you come right down to brass tacks, origin validation is just another way of doing policy on routes, right? So everything goes through the policy engine. There's a new match condition called validation database, which basically takes a route and bumps it against the contents of the validation database and pops back a result. And then you use your normal policy stanzas to set internal state, other state, and do stuff. So, I'll run through a quick example. But just to summarize what it's going to do, we're going to take the routes, bump them against the validation database, set the internal validation state variable, add a community for signaling the rest of our AS, set a local pref. We're going to reject invalids. You could also set a local pref, but I've just chosen to do it this way in the example. And also at the end, we define named validation communities. So, first stanza, this is divided up into 3 slides just because I didn't want to make eye charts. We say, okay, is this a BGP route? And the validation database valid thing just says if the route, you went and checked it in the validation database and found it to be valid according to the algorithm that other people get to describe, then what are we going to do? We're going to set the internal state variable, we're going to add the relevant community, and we're going to accept the route. Equivalently, if it returned invalid, then set the invalid state variable, et cetera, and reject it, because if your route's invalid, I don't want to be routing on it. And finally, there's only one choice left, and that's unknown. So we don't really have to go and do a match to that. It just falls through. And these are the IANA-defined values for the validation state. We will eventually provide convenience keywords, and you won't need to have these 3 lines in your policy, but right now you do need them. One thing that's worth noting about this is that all of the interaction with the selection process takes place by setting local pref or otherwise, doing stuff in policy. There are no magic side effects, so just because you set, validation state to something doesn't have any implications whatsoever for whether a route gets selected or doesn't get selected. If you want it selected, set its preference. If you don't want it selected, reject the route. So there's, as usual, a plethora of show commands that you can apply against this stuff, which, again, I'll only scratch the surface of. Show route is decorated with the validation state. One thing to observe that I think may be interesting, especially in context of Mark's talk where he said, hey, a lot of you guys aren't using this yet, is that, so remember I said that setting the validation state has no side effects. You have to explicitly do something in your policy if you want to start rejecting routes or whatever. So it's, and by the way, the computational cost and the memory cost of turning on RPKI router is really low. This is a cheap operation to do in your router. So if you want to get your feet wet, it would be, in my opinion, a very reasonable thing to, turn on, follow, something like that template that was on the previous few slides. Set the validation state. Don't do anything else. Don't mess with your local pref. Don't reject routes, whatever. Just turn on the validation state, and oh look, now you can go and do show commands against your router and just see what what the protocol is doing. It's not going to affect your operational state of your network at all. So yeah. Oh, by the way, interesting other tidbit is if you do that, you will note that or you may note that there is a fourth state that we represent in the show command, which is unverified, and what that means is just like it says, we never, if you never ran that policy stanza to go and set the internal state, the state will be unset, and this is the distinguished value for you never set the state. I have no idea whether this is valid, invalid, whatever. And unverified is not the same as unknown. Unverified just means you never tested. That's my time. Show validation statistics tells you a bunch of stuff about how hard the router is working at, how many things did you try to validate. I don't think I can read down each one of these things in detail. The validation database, I want to highlight one potentially interesting thing here, which is the router can be configured to peer with several different validating caches for robustness. So just like any other network protocol, the whole RPKI system is an eventual consistency system, meaning, if you wait long enough, everything is supposed to converge to, so that everybody has the same view on the RPKI. At any moment in time, different elements in the system may still be in the process of converging. So, that validating cache over there and that validating cache over there may have some disagreement about what the state of the world is. If you start digging into the configuration, the router, sorts them and says, I'm going to trust you, and then you, and then you, and then you, and so on. But that mismatch column over there will show if two of your validating caches are telling you different information. It wouldn't be shocking to see, like a few things in that column. If you saw that full of asterisks, you would probably want to scratch your head and start digging into it more deeply. Similar stuff. Yeah, and if you're familiar with the Junos documentation, I just read it to you, basically. So it's actually, this was the first time I went and looked at our documentation. It was remarkably accurate. I'm just going to shut up now. Thanks, everybody. And, you have any questions, come around afterwards.
So our third presentation from our router vendor is Arjun Srikanti of Cisco.
Hi, everybody. My name is Arjun, and I'm here to talk about Cisco's origin validation implementation based on RPKI. And hopefully, it won't sound too repetitive. So Cisco support for RPKI mainly comprises of the router software modifications to support the RFCs that were referred to earlier, 6810 and 6811. This comprises of the RPKI router protocol to download the ROAS and build the RPKI database on the router, and the BGP protocol modifications that use the RPKI database thus built to perform the origin validation on the routes that are received. So we have support for RPKI both in Cisco iOS and iOS XR. The iOS code that first supports this is iOS XC 3.5 and later. XR support is available for post XR 421. So the platform list is not exhaustive. We do have support in the newer platforms as well on the XR side, such as the XRV and NCS6K. So we do have support for RPKI and most of the platforms that we ship today. So in the next set of slides, I will talk a little bit about the CLI extensions made to support RPKI. The major modifications is in the route maps and the route policy on the XR. So the route maps on the iOS side have been extended to basically match based on the RPKI state that is set once the original validation is performed. So you can pretty much match on an invalid state and set a lower local pref, or you could match on a valid RPKI state and set a higher local pref. So you could implement policy to basically prefer a valid route and depreference invalid route. So this offers a means to basically implement policy selection and influence your best path selection in your IBGP domain. A bit into the config commands needed to enable RPKI on the router. So the RPKI server essentially enables the router to connect to a cache server, a cache validator, and download the validated ROA objects and build the RPKI database. That is the command that's necessary to enable RPKI on the router. Once that is done, the router connects to the ROA, the cache validator, and downloads the ROA objects to build the RPKI database. Optionally, you can also implement policy to prefer or deprefer a route. So you can implement essentially policy based on the path validation state. You can define local policy up to you, whatever you want to do with it, based on the path validation state that is set once the original validation is set. And that's using the route map statement per neighbor. A third configuration there is to basically enable the announcement of the RPKI state once the original validation is performed towards the IBGP peers. So once the RPKI state is computed on the route, you don't need to recompute the original validation on the remote IBGP peers that receive the route. So you can, in effect, you can signal the validity state in form of an extended community towards the IBGP domain, towards the rest of the peers. And that's basically what that config is enabling. So this avoids expensive recomputation of the original validation state on the other IBGP peers once the original validation has already been performed. So the shift command and the operational state reflects the validity state of the route. So each of the examples below, the route's been tagged with the appropriate validation state based on the original validation that's been performed. The route tagged as V is valid. Similarly, you have an invalid route without a best path tagged with I, and the end state essentially reflects that there is no ROA object corresponding to that route, and hence the state is essentially not found. So we have support to basically display the RPKI database that is built as a result of downloading the rows from the cache validator. So this is in form of the network and max length that was talked about earlier, and the corresponding origin AS that is authorized to advertise this prefix. So the show commands into the prefix output, the route output is enhanced to display the RPKI state. So for this particular route output, there is a covering ROA entry in the RPKI database, and the origin AS matches, hence the RPKI state is valid. And that is reflected in the prefix output. Similarly, for another prefix, there is the origin AS does not match with the entry found in the RPKI database, and hence the RPKI state is invalid for that route. Hence, the default action is to basically exclude this route, exclude the path, which has been marked invalid from a best path calculation, and hence the prefix shows with no best path. Similarly, when the ROA entry is not present in the RPKI database, we mark the routes with not found, but still include them in the best path calculation. So the next set of slides are analogous to XR, iOS XR. So for those of you who have used it, you know the equivalent of route maps is the RPL in iOS XR route policy. So the route policy has also been enhanced to take into account the validation state and set appropriate policy based on the validation state match. You can depreference or prefer a route based on the validation state, as we've seen earlier in XR as well. So the config commands are analogous in XR to the iOS statements. So you have the RPKI cache statement, which basically enables one to connect, enables the router to connect to cache validator server and download the validated ROAs to build the RPKI database. You can apply policy using the RPKI, the route policy RPKI statement there, which identifies a policy to match based on the validation state and set an appropriate preference, for example. So in addition, we also have the validation signal IBGP config, which basically enables you to signal the validation state to other IBGP peers, like we talked about. So this basically signals the validation state in form of an extended community towards all the IBGP peers. So similar extensions to the table output in XR to tag the routes with the appropriate validation state. A similar command to basically display the RPKI database built as a result of the download of the ROAs. And the prefix output has similarly been enhanced to display the validity state on the route. So summarize and recap, the main aspects of the implementation are the implementation of the RPKI router protocol, which basically connects to the cache server and downloads the validated ROAs to build the RPKI database on the router. The BGP changes, the protocol changes needed for original validation, which perform the original validation as per the RFC procedure using the RPKI database that's built. And we have support for the extended community to signal the validation state, thus computed towards other IBGP peers to avoid the recomputation. So the RPKI router, so both iOS and XR support the client part of the RPKI router, which basically downloads the validated ROAs to build the RPKI database. iOS supports TCP as a mode of transport. XR has both TCP and SSH as a mode of transport to connect to the cache validator. The BGP protocol modifications, they're defined in 6811, RFC 6811. So we support validation, original validation for both IPv4 and IPv6 FEs. So the validated ROAs are downloaded as a 3-tuple origin AS along with the associated prefix and max length. That's received via the RPKI router protocol, and it's used to build the database that we have seen in the show outputs. So that's used towards the validation of incoming route updates, and the origin validation performed cross-checks against the origin AS on the route with that present in the RPKI database and sets path validation state appropriately. You can apply inbound policies, as we've seen, to set, based on the path validation set, you can apply the appropriate policy, such as defining a local pref on the route. So the BGP best path has also been modified to take into account path validation state information. By default, invalid prefixes are excluded from the best path. So any path marked as invalid is not included in the best path calculation. So the changes to update generation, you can use the path validation state to set policy outbound as well. The route maps can be used inbound or outbound as you decide what policy to implement. So we do, as we've seen, we support the extended community to signal the validation state towards IBGP peers. That helps essentially avoid the recomputation of the path validation state on the remote speaker and essentially does the computation only once for a route in the IBGP domain. So that's about it. Any questions?
We have a very full track, and we threatened all the speakers with staying within their time. I noticed how precisely you ended at your assigned times. We're going to hope to have some time left at the end of the session for questions related to all speakers, and I don't know where to head. Oh, okay.
But we need to switch panels. We need to switch panels. Yes. So at this time, we're going to sort of switch the conversation from technologies and products to tools and actual deployment experience.
There we go. This is not the interface on my Mac.
Have to advance your way along.
So there's a bunch of us who've been working on various different tools that you might need in the deployment of RPKI. You might want testing, you might want to experiment with things, you might want to emulate the environment, you might want to be monitoring sorts of things, you might want to measure. We have people here who will be talking about a lot of the tools that have been developed for use in deployment of RPKI. And first up is Matthias Wallisch from Free University at Berlin. And I hope I have gotten that somewhere close to appropriate pronunciation. Okay, it's not there. That's the PDF version. You probably want the non-PDF, don't you? It's not there. Okay. Okay.
Okay, hello everybody. In this presentation, I want to give you a brief overview about two open source projects that we co-founded and still maintain. It's namely the RTR Lab and the RPKI Miro. That both are tools to monitor, test, and deploy origin validation and the resource public key infrastructure. Okay, so we'll start with the RTR Lab and then discuss the RPKI Miro. What is the RTR Lab? The RTR Lab is a library that implements the router part of the origin validation, which basically means it fetches the validated prefixes from a cache server, stores the data locally in a data structure, and keeps this data structure in sync. It also provides you with functions to validate an arbitrary prefix and check if the origin is correct or not. This library is implemented in C and as such highly efficient and resource friendly. It supports all relevant RFCs and internet drafts. This does not only relate to origin validation, but also to BGP-SEC. This means it supports the current latest version of the BGP-SEC drafts, and as soon as BGP-SEC is standardized, it will also be updated. It's open source and available on GitHub. Here's a brief overview where this piece of software is located in the overall RPKI architecture. As I said, it is implements the router part, so usually we will run it as on the router itself or use it to monitor RPKI from a router perspective. On top of this library, there has been a lot of applications available. This library supports origin validation in two very prominent open source BGP daemons, Quagga and Bird. At the moment, the implementation is available in separated forks, but these branches will be merged soon in the master branch of both daemons. There are also applications that allows you to monitor the origin validation. We have developed a REST interface as well as extensions for the CADA BGP stream, which was mentioned in the first session today. It's a hackathon. We have also developed a little plugin for a browser that gives you a brief insight if the web server infrastructure is secured by the RPKI in the sense of if their ROAS has been created or not. What is the advantage to use the RTI lib for monitoring instead of using, for example, the validator itself? For example, the WIPE validator provides also insights in the ROAS. The advantage is that you are independent of specific cache server implementation, which makes it, much more easy to change the cache server underneath, for example. And also, if you think about redundancy, it makes sense not to rely on a specific cache server. We also provide a tool chain that allows you to emulate origin validation of your BGP router. For example, if you cannot update the firmware of your router or the current firmware does not support origin validation. And what we propose here is to peer with, using BGPmon from the Colorado State, peer with your BGP router, and this BGPmon then transfers the BGP updates to XML, and then there's a little tool that validates the BGP updates based on RPKI data. And finally, there's a little web front end, that dashboard, which shows you how the validation would look like from your router perspective. And in contrast to existing dashboards like the dashboard from WIPE, this all happens in near real time. And the second tool I want to briefly talk about is RPKI Miro. RPKI Miro is a monitoring and inspection tool for RPKI objects, which means it collects RPKI data, all RPKI objects from the distributed repositories. That's the back end. There's also a front end that gives you an intuitive view into the RPKI objects, and there's also a statistical analysis engine. Again, it's also open source and publicly available. So again, a brief look how this is placed in the RPKI architecture. So it is between the cache server and the distributed repositories. Here you see a brief screenshot from the GUI, the graphical interface. That's a web application. You can open it. It's again also publicly available. That was not by intention. Okay, I can also use it. So you can, it's currently this public version supports all publicly available CAs from all regional internet agencies, but also some delegated CAs. So on the left-hand side, you see the certificates, certificate browser, and the relation between the certificates and the manifest, for example, or certification revocation list, as well as the ROAS. So this is easy front-end for you that you can check if the RPKI repositories, the distributed RPKI repositories, includes the data that you would expect that it should include. There's also a statistical overview that shows you which the amount of data that is valid and invalid, here we are, for the different CAs. So you can easily check if there's some error or not. Yes, whoops, that is, so how can I come back to the, oops, nope, here we are. So, we talked about that, and yes, and at the back end, this framework supports distributed probes, such that you can monitor the distributed repository from different vantage points and see if there are inconsistencies or not. At the moment, it only fetches the data from the repositories using AirSync, but we're also working on supporting the data protocol. As I said, the currently publicly available browser includes mainly the 5 IRs CAs, but if you want not to host this at your site, you can also let us know your CA if you implemented a delegated RPKI model, and we can add this for you. All of this two projects. Both projects are open source projects. They are hosted on GitHub. I'm actually a researcher, but these two projects are not weird short-term research shots, but actually intended to be long-term maintained and deployed. There are already users for both tools. Feel free to use it, but also to contribute to these projects. So that's from my side.
Oh, I should have gone. Okay. So I deliberately put Matthias first on the agenda because some of the things that I'm going to be talking about are things that we are doing that are similar to stuff that he's doing with a little bit different focus. We have several different tools that we've been building to try to facilitate deployment. There's a set here that I'm going to be talking about the first three in detail, the last one not so much detail. The first is a workshop in a box intended for internal training if you want to try to experiment with routing policies and see what the impact would be on the routing table in your system or in a hypothetical system. Lets you play with any sort of prefixes, not just your own. The second is intended for something you could use to emulate what the impact would be if you turned RPKI on. It looks at your local routing table. There are various monitoring sites that will tell you what the validity state would be in the global routing system. There's RPKI visualization, which we actually call RPKI Viz because there's a not accidental relationship to the intent of DNS Viz. We're trying to copy the same model of being useful in terms of visualization. The RPKI monitor, I'm not going to talk about too much. We've talked about the RPKI router protocol that has a router end and a cache end. It's the passing of information between the two. There's a MIB for the router end. So this is an SNMP monitoring for the router, monitoring the MIB on the router for what the state of the cache is on the router end. Last time that you contacted the cache and what the size is. And then it also talks to the cache end to see what the status is on the cache end. Not going to talk about it all that much because we've discovered that the router vendors haven't actually implemented the MIB yet. And not going to talk about the cache end very much because there's no MIB associated with the cache, so it has to be implementation-specific monitoring of the various different cache implementations, the validating caches. Okay, so many of you know of or have seen, it has been to NANOG, the global traveling workshop that Randy Bush actually was the instigator and has held it on many different networking venues across the world. It involved 2 operational routers connected to the internet announcing ARIN experimental prefixes and actual Cisco iOS images running over Dynamips. We wanted to put this in a box so we could hand it out to people, so we couldn't exactly use an operational router, and we couldn't use an operational prefix, and we couldn't use Cisco iOS versions because we couldn't hand it out to people that we didn't know what the license was. So we're using open source routers. We're actually using the NIST Quagga SRX routers. So there's a bunch of virtual machines here running Quagga SRX, and they're the student routers. The students can log into these and we're using 2 instances of Bird to be the announcing routers. So the workshop in a box comes pre-configured with IANA, a virtual IANA, not the real IANA, so that you can allocate yourself any prefixes you want, and it comes configured with a set of student users that can use this interface. And then you can look at the workshop system. The dashboard here shows you a prefix that I'm familiar with being allocated to the workshop. And the interface allows you to create ROAs. It allows you to show if you've allocated some of the resources, if you've not allocated some of the resources. The Ghostbuster records is something that's defined in the RPKI to say, if there's a problem that you see, here's who you might try to contact. With this GUI, you can look, it downloads the routing table, and you can look at what the current state in the RPKI is for the routing table that is globally seen. You can try to create a ROA for some of the addresses you hold. It'll give you an opportunity to say, if I create this ROA, here's what the impact would be on the global routing table. Sometimes when you create a ROA, you make that you create one announcement ROA authorization, and then other things become invalid. And then you can log into the routers and see what the impact is. You can try to hijack the other students' prefixes and see what the impact would be. On to the emulation and operation monitoring. This is a tool that speaks to a BGP router on one end over using a trigger script, not a BGP, as Matthias's example does. It speaks to a cache on the other side, and the idea is that this would tell you what the impact would be on the routes that you receive if you should happen to turn on RPKI services on that router. You might also be using it once you actually did deploy to kind of check on the monitor the status of things. So on one case, it shows you the route status for all the routes in the table. It will also show you what ROAs create that state. So if it's valid, it shows you what ROA makes it valid. If it's invalid, it will tell you what ROA, who the authorized originator is, so that you can go check the RPKI. And then it also gives you the status of the routers and the caches that you're speaking to. And there can be several, so there's a list in each case. It has the usual sort of show IPBGP command line interface, but again, it adds to that the validity state and the ROA that produces that validity state in the RPKI. And RPKI visualization shows you the whole tree. This one particular example is kind of interesting because the chosen subject in this case was a prefix that was in the process of transferring from ARIN to RIPE. So it actually shows up in the ARIN tree and the RIPE tree, and RIPE also has an experimental tree that, and it shows up there as well. And it displays for one particular object that you highlighted, it displays all the broken out contents. It will point out if there are errors. It'll flag the errors and tell you exactly what the problem is, expiration times, problems with the resource not belonging to the parent. It'll give you a history. I swear this was valid yesterday, and so it gives a history of when the ROAs were present and when they've appeared or disappeared. And it'll also show you a warning. This particular object's signature is about to expire. Remember me mentioning that Ghostbusters record? Well, this is a case where you might want, if this is somewhere higher in the certificate tree, you might want to call someone and say, you need to refresh your certificate because it's about to expire and it will affect me. You can use this to look at your neighbor's certificates and see what their status is. And then we're going to proceed to the NIST tools.
Restart my timer since I seem to need it the most. So like many organizations, we are also in the business of building tools to try to foster RPKI deployment. We're going to talk about 3 different tools today. Actually, if you download the slides, at the back of them, this is generally a survey of various tools and diagnostic technologies out there. There's even a longer list at the end of the slides. So I'm going to talk about 3 things today. One is a persistent RPKI monitor that we run. The second is another software router prototype that's maybe structured in a slightly different way for research and experimentation purposes, and a different kind of test system that we've built that allows you to run RPKI experiments on real commercial router implementations. So the RPKI monitor, the NIST RPKI monitor, is a continuous monitoring service. It's a site on the internet. There's somewhere in here is a URL that's focused on 2 different things. One is to try to characterize like the size and the shape of the RPKI, right? And so this is strictly on the object creation side, looking at the creation of certificates and ROAs across all the regions. The second side of that, of course, is taking data from a bunch of public BGP repositories and comparing them to the ROA data, right? So we do route origin validation against a large collection of prefix origin pairs that we see. The tool itself provides multiple views. There's both snapshots of the current instantaneous state of affairs and historical data to watch trends. Anytime there's a statistic on the site, there's a graph on the site, there's a compare button that typically gives you a comparison across all the different regions in one quick snapshot. We're also interested in looking at top adopters in various ways of which organizations are actually deploying ROAs and have valid or invalid routes, and you can query specific data out of it. There's a few things that we're adding to this. One is what we call RPKI origin validation anomaly detection, both looking for interesting changes in the structure of the RPKI and trying to correlate changes in RPKI data to changes in route validation state. Currently, we characterize RPKI structure in sort of a static way. We're also trying to capture the dynamics of that, how it grows and changes over time. And right now, our monitor is using 2 of the validating cache implementations. We're actually just going to add the 3rd into it and sort of run a persistent validator interoperability testing, is comparing the data sets. So I noticed talked about two types of analysis. We look at comparing all the RPKI, the ROA data, to all the collected prefix origin pairs that we can find in the internet. We look at the relative rate of valid, invalid, and unknown. We drill down and look at the state of error conditions for the those that are invalid, trying to characterize why they're invalid. We also produce things like heat maps of the depth of the RPKI certificate tree. Sorry, I left the key off, but if you go to the site, you'll find the key, of characterizing the global IPv4 space in terms of sort of the maturity and the depth of the RPKI certificates in those different regions and address space. The other thing we do is track early adopters in various ways, both globally and by region, looking at those ASs that have the most prefixes or /24 equivalents that are valid by RPKI. Those are sort of off to a good start. And we also characterize those that are not off to such a great start, is looking at either from the AS side or the prefix owner side, those who have the most prefixes or address space equivalents that are invalid by RPKI. As I noted, any of the graphs or statistics out there that you see, if you hit a compare button, it'll instantly throw up both global and all 5 region statistics side by side, so you can begin to compare those. The second tool I'll talk about is a research prototype that we call BGP SRX, Secure Routing Extension. It's a software, Quagga-based software router that does the components implement the router to cache protocol and do BGP origin validation. We built this prototype to experiment with different deployment architectures of both RPKI origin validation and eventually path validation. And so our BGP SRX implementation has a separate process that does origin validation, all right? And you can run that process either on the router, on some node, in between the router and the validating cache, or potentially on the validating cache. Part of our goal was to look at the way in which we can possibly completely minimize the impact of origin validation and eventually path validation on an existing router. BGP SRX is up. There's source code and a Yum repository out there that does origin validation with an SRX server. Actually, the implementation out there also does path validation, but that's the topic of a different talk. So once again, the idea here is to put the functionality in a separate server process, so you can have a BGP SRX server that serves multiple routers, right? SRX talks to the validating cache. Even though we were talking about the highly distilled set of ROA data, in this case, it keeps it off board, off the router in this separate process. One router, one BGP SRX server can serve multiple routers, or you could deploy multiple SRX servers within your autonomous system. We do have a small protocol on the wire, right? So we say we're doing all the origin validation in a separate process. We do have a small protocol on the wire that makes queries from the BGP router to our validation engine and get results back. It's a picture of the software architecture, too detailed for this talk, only to know that, once again, we are trying to minimize the impact on the running implementation with a very thin proxy that we put in the Quagga implementation to make calls out to our validating engine and get the results back. There's a set of policies that we implement, once again, meant to allow you to do experimentation and explore, both the typical ignore kinds of policies based upon validation state or to increment or decrement local pref. The last test tool I'll talk to you about is something slightly different, a little bit maybe akin to Workshop in a Box, but different, right? It's a running service that we call BRIGHT, which was some clever acronym for BGP-Sec, RPKI, Interoperability, and Test and Evaluation. What it is a web-based server that we run that allow you to run experiments against a real router, where we step in and provide both what would be the output of router to cache, RPKI to router. So we feed you the distilled list of ROAs, and then we feed you BGP streams, right? We both feed you BGP streams and field BGP streams back. The idea is to allow you to take a new implementation, hopefully from a commercial vendor, and begin to understand and explore how their policies work without having to set up the test infrastructure yourself. It's recommended that this be, a quiet router that's not actually really doing anything, because we're going to feed you real data and real BGP streams into the box. There's XML-based test scripts that allow you to go through a bunch of tests that we define that allow you to exercise different policies. They're specifically set up to allow you to exercise the typical types of policies that you can implement in a router. Ignoring routes based upon validation state, local prefing routes based upon validation state. So there's a whole list of canned scenarios there. It's also an XML-based test language, so if you look at the test languages, the test scripts which are online, you could easily dream up and write your own test scripts. When you log into the system, right, you connect to the system that's running at NIST. There's a long list of existing test scenarios that you can choose from. You choose a test scenario and kick it off to be started. And then there's sort of an execution screen that tells you the addresses to connect to our, if you will, emulated validation cache, because we're going to send you RPKI to router, and where the address is to open BGP sessions to us, because we are going to feed you both BGP announcements and take, right, BGP updates from you to see if you have implemented the policy correctly, right? Each of the test scenarios asked you to explore a specific policy. that system is online. You can connect to it today. You can run, I think we have 20-some sort of test scenarios there. And now we're going to switch off of tools to deployment experiences and panels and our question and answer. And we thought it was important to find those of us in the community who have actually deployed RPKI in some part of the equation. We have experiences to report from large enterprise users, ISPs, and the IXP community. And so to kick that off, we're going to start with Rick Mayberry of Microsoft, who will tell us about what they've been doing with RPKI. Don't think I'm coming back here. Good.
So I guess Mark introduced me a little bit earlier and didn't realize it, but I'm the one person that's operating a delegated repository today. There's a quick update there. He said that we weren't like publishing anything, but as of late last week we are. So I figured it would be inappropriate for me to get up here and encourage everyone to publish your own ROAs if I wasn't doing that myself. So I think Microsoft, all of our global IP space, probably by the end of the month, probably 95% of our global IP space will have ROAs associated with it. So I'm JR, I run the cloud network security team for Microsoft Azure. We actually run the entire network for all of Microsoft's online services. And so why do we care about RPKI? So if you're a cloud service provider today, there's two things at the top of your mind. It's security and it's reliability. And when you look at the impact of a route hijack, it's going to involve those two things. It's going to impact those two things. The downside is only detective solutions are effective today. And so we're definitely looking for a way to have preventative measures in place on a global basis to protect Microsoft from prefix hijacking. The thing that I'm trying to encourage is that the RIRs have made it super simple. Like, I realize we went through a lot of content today that may seem like a lot, but if you were to go into the RIPE portal or the ARIN portal today, you could have ROAs published within minutes. So I think I'm trying to demystify the adoption of RPKI so that more people feel less anxious about doing it. I'll give some context on sort of my problem statement. The services that I'm protecting today include Skype, Azure, Bing, Hotmail, Office 365. So we have a global network. You can see from the graph, we've got 28 regional data centers for Azure. I've got prefixes from 4 different RIRs, something like 20 million plus V4 addresses and 576 billion IPv6/64. So that's what's at stake for me. So again, I am the delegated person, and so a lot of this is going to be in the context of a delegated model to give you some decision-making framework for whether a hosted model or a delegated model is more appropriate for you. I outlined sort of like what I thought was 10 easy steps, but really I'm just going to tackle sort of what the issues might be. The first thing to know is that your ROAs are as dynamic as your routing policy is. And so if you've got IP space that's moving between ASNs, if you've got changes in prefix lengths, if you've got new IP space that's being added on a regular basis, so like if you're a growing dynamic organization, your ROAs are going to reflect that. And you need to make sure that you have the processes in place to reflect that as well. The other thing I would say everyone should educate themselves, there's 2 papers out there about reasons to not adopt RPKI. One is it's called the the risk of a misbehaving RPKI authority or something like that. It's a paper that basically says you're giving the regional internet registries power over sort of like black holing entire organizations using RPKI as a method to do that. The other one is on the legal indemnification of ARIN if you get services through ARIN. I think it was something that came up in my peer group within Microsoft that I wasn't educated on. My guess is that your organizations have probably read similar papers, and I would advise just being educated on like some of these and form your own opinion about it. Two other things, we talked about the scale model. So with RPKI, you publish a repository, right? So rsync is TCP based. You publish essentially a URL for that repository, which can be DNS based. So creating a high availability, geographic dispersed, scaling model, it's actually really easy using global server load balancing. Let DNS do the work, put your infrastructure up around the globe, and it's really that simple. The two things that I would say about securing RPKI is actually it's fairly simple because, again, the only thing that you're exposing is your TCP endpoint for rsync. And you can also create a hierarchy of rsync servers, so you can have your master RPKI server where your certificates and your private keys are, and your master rsync server is, and then you can create a series of slaves globally that pull from that rsync server, so only your slaves are exposed and your master is really protected. The other thing I would say is we were having an email thread is I feel like one of the weakest links in this whole thing is going to be who has administrative access to your RIR portal and what credentials are they using. I think some of the RIRs support two-factor authentication today, and so that would probably be highly suggested. But if someone has access to your RIR portal, they can publish ROAs on your behalf. They can, change your repository. There's all kinds of things that they could potentially do. The other thing I would say is to plan recovery from breach and catastrophic failure. So the RPKI net tools, which is the predominant open source software that's out there today, does not have support for a hardware security module like the RIRs do. So you're essentially, depending on how you secure it, you could potentially have your private key sitting on your server. And so you want to make sure that you've got a design in place that's protecting those keys, but you should also have some plan in place to recover from breach, which it's actually fairly easy just to cover that. You can just remove all your ROAs from your cache, and then you can rebuild from there. And once your ROAs are not found, there's no risk of someone's router policy impacting your network. So on the ARIN portal, they have a FAQ of why should I go hosted, why should I go delegated. They suggest sort of the way they answer the FAQ, if I remember right, is they say that if you have downstream customers that may want to publish ROAs, they're using your IP space, you've delegated it to them, they want to publish either on their own or within your ROA repository, then that would sort of be a predominant use case. I think there's probably some more questions to ask yourself. If you have more than one RIR, that would definitely be a use case. If you have an organizational policy that requires you to have an HSM, then that would be a reason to not do hosted. It's also, how do you feel about an RIR running sort of a critical service and critical infrastructure on your behalf? Is that something that you feel you could operate better than the register or the RIR? So for me, the first thing I'll say is for the RPKI net tools, there's a new development fork that's coming. The one that's out there today sort of is not actively developed or actively supported. I want to be careful how I frame that. But being sort of one of a few people that run a delegated model, your community of other users, it's not like other large open source projects where you've got this vast community of users and this vast support model that you can pull from when you have issues. You're going to be one of a few people in the entire world that's operating an RPKI, not .NET infrastructure. And so I think there's inherent risk in putting critical infrastructure in that state. You have to be really comfortable with Python, really comfortable with writing your own code, and debugging code on your own as well. I think the other thing is, within an organization like Microsoft, it's sort of when you see other companies that are impacted by route hijacks, your leadership is inherently going to say to you, what are we doing to mitigate this attack? And if your response is RPKI, there's inevitably someone that's going to say, well, that's a long-term solution. There's really no value in doing that today. And so you have to sort of have the confidence to say that there is a longer-term picture. This is like, we need to be doing this. It's part of the overall industry direction on why we should be doing it. But that's definitely something to consider. The other thing is that if you have invalid prefixes, you're not necessarily going to know who's enforcing policy based on those prefixes. As far as I know, there's not a place that you can go and see, oh, I had an invalid prefix. How did the global internet react to that? And was it related? Did my outage that I had, or did that convergence that I saw, was that a direct result of that invalid ROA? So that's another thing to be conscious about. The last thing I'll say is that monitoring is, like, we talked a lot about monitoring. I can't emphasize enough how important that is. I looked at the data, and there's 10% of the ROAs that are published today are invalid. A large portion of those are because of prefix length issues. I think probably half are. And so it's super important that if you're monitoring your infrastructure, you're monitoring your ROAs, you're doing whatever you can to know that if your system is broken, that you're aware of it and that you can react to it, because it's going to happen. All right, thank you.
Next up is Tony Tolber of Comcast.
Hi, folks. I didn't have slides, so that's why we see beautiful El Capitan. JR did a great job of highlighting, the basic things to think about. My experience that I share is I worked with our ARIN point of contact to publish a couple of ROAs in a hosted model. A while back, my intention has been to revisit it. Somehow it keeps falling on the back burner, which is a bit of a challenge. Probably, depending on the size of your organization, the ARIN contact might be a different person than a network engineering. They may be sort of an addressing manager. So the person who has access to the RIR user interface. That was the case in our situation, so I had to work with the folks there to get the stuff published and signed correctly. Then when, if you've got delegations to other entities, downstream customers, you've got to work through the business rules of that, how they, how you get the stuff published. I mean, if you're doing WHOIS stuff, if you're populating WHOIS information for them, it could follow that. As far as staffing, obviously you want it not to be a single point of failure. I mean, my goal is not to be, oh, some weird RPKI thing happened, call Tony, right? That's, you're going to have to make sure that there's adequate training and for all the folks who normally troubleshoot BGP, right? As far as tools, we've had a pretty good coverage here. I'm encouraged by the considerable development effort that all the folks have done. Many nonprofit entities, and that's very helpful. But you have to think about the support model, for the tools, for the validation software. That's not a as far as I know, there's no vendor support for that. And then also, if you think about the AS structure, for us, we are complicated. There's a lot of people who have complicated situations, but for us, we have several, a couple dozen ASNs. different relationships between them, transit and so forth. And so but our large address blocks are assigned to our entity, and then, we move them among different ASNs. And so, as JR mentioned, you have to manage that dynamism in your, in your software and your business rules. And, maybe something like the RESTful interface could, if you're using an Aaron model, can help with that, managing that stuff. But you obviously don't, you have to keep the flexibility that you want to maintain in mind when you design the implementation for you guys. And then, given that the ASN model where we've got, a couple dozen ASNs, it would be great if you could have sort of either overlapping records or something like that, where you kind of whitelist in a number of different ASNs, whitelisting in a number of different possible lengths is, that might be complicating things too much. But these are things that have come to mind for us, and still have to work through in the design phase. So we don't have the end of the story, only really just the beginning. But if people have things that they want to ask me or discuss with me or suggestions, it's all part of getting the community launched. So that's it for me. Thanks.
So if you look at any of the global monitors that compare regions, you'll notice that RPKI adoption in Europe, in RIPE, is significantly ahead of that in North America. And we're fortunate today to have two talks from IXPs in the RIPE region who are taking significant steps. Our first speaker is Christoph Dietzel, not Thomas King, from DKIX.
Hi, yeah, my name is Thomas King. No, actually not. So apologies from Thomas. He got some sort of migraine earlier today, so I'm the replacement, and I'm just going to walk you through the signaling prefix origin validation results from a route server to peers. So as an IXP, we always like to boost the acceptance of usage of RPKA-based prefix origin validation. So we think this is a good step to make the internet routing system more secure. And we all have seen the need for this. Oh, yeah, sorry about that. Yeah. So we clearly have seen the need for this. We see hijacks, we see malicious things going on in the internet routing system. So we as an IXP incentivize that we want to have origin validation. And we also want to increase, as an IXP, the data quality at IXP's route servers. So what we want is, we want to provide you through the route server with prefixes that are filtered and that are validated to assure you a very good service. So naturally, IXPs come with a setup that could be sort of convenient for deployment of RPKI sort of delegation. So if we think of, if customers at the IXP want to do route validation, RPKI validation, then we just think of a bunch of routers there that are there established for a couple of years. They are bought, and it was an investment, and you don't want to switch. You don't want to change the operating system you got. So by now, as a customer at the IXP, you don't have a mean to do the validation. However, the route server as a central instance allows us to delegate the RPKI validation. So this is a very simple concept, and it was introduced by, or some customers came to us and said, okay, we have this route server there, and as an additional service, we can envision that you provide this to us, so we don't have to implement it. Maybe we can later on switch on our own to our own stuff, but in the first place, we can rely on your implementation. So this also raises a concern because the information, the validation, which can be performed on a route server on commodity hardware, has to be signaled towards the routers of our customers. And this can be done through a new concept we came up with. And this concept is very easy. And we want to signal through communities, extended communities, to signal validate, invalidate, or not found routes. So coming up with this concept, we work together with the other IXPs here to really write an internet draft to standardize this so that it can be used all over the place, so that not each IXP comes up with its own set of communities and it's always implemented in a different way. We all know this with communities, they are mostly not that well standardized. So DKIX work together with the AMSIX and FranceIX to really have one standardized version to use the communities, extended communities, to signal whether a route is valid, invalid, or it could not be found. And for now, this has been accepted by the SIDR working group as a working group document. So to really report a bit more on our experiences, we can really say that the organization of the IXPs within Europe, the EuroIX people worked well together and really got to the point that it really makes sense to standardize things, to really, for RPKI to really have a huge user base, we need to make it easy for people to use it. And one way is to provide it in a standardized way. And there was also a lot of interest in the community. Some didn't like the concept because they don't believe too much in route servers. However, there is a huge number of customers that value this concept and really like the idea and encourage us to push forward with this new thing. And for now, the deployment of the RPKA at our IXP is not that common. We see about 9% of all prefixes available at the route server are covered by NROA. I'm going to give a talk tomorrow morning, so I have more numbers and details on what exactly are the issues, who is using it, and why are they not valid, what's the root cause of that. As pointed out earlier today, the max length is always an issue. And for us, the prototyping part was very easy, so we could just take a piece of software and implement it and use the RIPE NCC validator for it and the RTRlib, so tools which are actually there. What the issue now is to put it or to bring it to production, because we talked to the RIPE guys, for instance, they were, okay, but you're not seriously using it for production? And so no, not so far. And this is also a concern many people had and have, like if you push too fast forward with a new technology, that the implementation may not be as sound as it's supposed to be. However, the RIPE guys, for instance, taking care of this now and working on a version 2.0, which is supposed to be more stable and production ready. So what are our next steps? Obviously, as we saw today, the RPKI is a chicken-egg problem. It's very hard to push people to do the first step, to do an effort, and not really gaining the benefit right away, maybe later on. And yeah, we need to enhance our prototype implementation to really provide it as a service. I mean, proof of concept is easy. So, and we want to provide more control for customers, better monitoring capabilities, so that you, if you use this service at the IXP, that you not just get a prefix annotated with invalid, but that you rather can really look into it and sort of debug it, so that you have, through the looking glass or whatsoever, some means to debug why things don't work. And we need, as I pointed out earlier, a stable tool chain using or relying mostly on third-party hardware, software implementations. Yeah, and we hope to release the prefix origin validation at the route server feature in 2016. Nah, maybe not, but we're really working on it. And yeah, as I said, our aim is to really put the bar as low as possible for people to use RPKI, because we as an IXP believe in good service and quality prefixes. Thank you.
So continuing our learning from the experiences of deployment in the RIPE community, we have Hank Steenman of AMSIX, who will talk about their deployment experiences.
Yeah. Good afternoon. Thank you, Christoph, for the very nice introduction. So we basically do exactly the same thing as Christoph described in his pictures. We started with a beta program roughly 9 months ago. It's been running pretty stable, pretty well. We have implemented 2 route servers based on BERT. They do RPKI prefix validation. And this presentation is basically about some of the results we see. So, as Christoph also said, we provide basically the means to distinguish prefixes based on origin validation. And we do that by applying a community to each prefix, being valid, invalid, or unknown. And then we allow the route server peers through our web portal to define which of these prefixes they want to receive, either everything or everything that's valid or whatever. We give a series of options, and through these options they can define that themselves. So results that we saw roughly last month. We have 101 peers on the route servers. On IPv4 and 69 on IPv6, and we see that roughly 15% have a prefix validation or an origin validation, and roughly about 12% of those are valid and 2% are invalid. Now compare that with our default route servers that do not do origin validation and that are running there for a couple of years already. These have over 650 peers instead of 101, so roughly 6 times more. Anyway, the number is growing, and that's the important thing here. When we started out, there were originally roughly 20 peers on IPv4, and in these 9 months, the number has increased 5 times. So, what do peers do with this information? So 53, roughly half of them, explicitly define that they want to receive all prefixes, but tagged according to the ROA status of the RPKI origin validation or the Internet Registry route object existence. That's another kind of tagging that we do. 13 peers explicitly route on the origin validation and say they do not want to receive these routes, and 0 peers do not want to receive routes that are only the ROA invalid tag, and it's similar for IPv6. So of the invalids, it's only 2%, but still it's a considerable number. We looked into that, what they really are, and as it turned out, they were not really invalids in the sense that they were not hijacked prefixes. 55%, a little bit over half, is just more specifics underneath the object with the validation, or it's an assignment to downstream customers, and which is another large part. And then there's a couple that are no longer valid because of company acquisitions and mergers, where prefixes move to another AS and the database was not updated. And then there's a couple that are just misconfigurations or negligence or whatever. For example, IGP leakage. So all in all, there's not really, it's just how to say that in English? Negligence. It's not, there's nothing really serious going on, at least not what we can see. As Christopher said, we use the RIPE RPKI ROA validator and the RDB trust anchors, of which this is a snapshot. And that's about it. So what we see is more uptake. We see more and more routes being validated. The whole usage is growing, but it's still very, very small. We currently only do this on the Amsterdam exchange. We will extend it to the US exchanges and the other international exchanges. But we first want to have more experience, more feel with the community, what they really want and want to get out of this.
So now we'd like to open the mics for questions, not only of the deployment and experience and tools panel members, but also of the technologies, services, and router implementations of this morning. You must have some questions. Don't be shy. Well, I'll start. Maybe I'll start. So JR, you know, it was very encouraging to hear that by the end of the month, we won't hold you to that, but Microsoft is moving towards having ROAs published for 95% of its address space. I wonder if you could comment on the other side of the equation of, you know, can you see a timeline for when Microsoft might start filtering on that information? Clearly, you hope that someone is filtering on it.
So I mean, I think that's a good question. I might take the easy answer out and say, I'm not on the core team, so I don't that's up to them to decide that policy. But yeah, there's no specific timeline right now, and I'm not sure at what point we make that decision either. Like, I'm not sure what circumstances lead us to do that. I think the best thing for us is when everyone else does it.
Thank you, Ed said. You said something about you can't tell whether people are actually filtering on that someplace else in the world. Looking glasses have been something that operators have used forever. I actually know of at least one that reports origin validation state. Do you see any way to encourage looking glasses to import the RPKI data so they can report that sort of stuff?
It seems like a no-brainer, right?
I'll add, I think, you know, perhaps some of these sort of meta BGP watching tools that, you know, like the BGP stream and BGP Mon, which is different from the BGP Mon service, but there's, you know, some API tools to get BGP information from, you know, many of these looking glass and you know, the route views and the RISs of the world, right? Maybe sort of the grand wrapped up view and, you know, sort of global sense of where in the world there might be black holes because some, you know, some ROA conflict, especially for your address space, right? You want to know for your address space, is something bad happening because of this? And, you know, that's obviously a big question that the business owners want to answer too, is like, okay, unknown we think will keep us safe because there's so much in the unknown bucket that people aren't acting on it. So if you start to go there and you screw it up, are you more at risk? You know, that's going to be a question that, you know, you may find yourself getting asked.
Oh, go ahead.
Henk, you said take-up has been kind of slow because since last fall, you've only managed to get 1/6 of your people. I can't imagine what the uptake was after IPv6, how long it took to get to 16%. I think it's actually, for a brand new technology, it's rather significant. So don't sell yourself short.
Actually, routers connected to the exchange using an IPv6 address went pretty quick.
Yeah.
But actually shipping IPv6 traffic, that just never happened.
Christina.
Hello, Christina Chu, NTT. I have a question for DKIX and M6. I'm wondering, the customers that you have requested RPKI, what type of customers are they? Are they ISPs, enterprise?
I think they're from all over, whatever. I don't think there's a specific category that stands out as users of RPKI.
Oh, interesting.
But typically you can say that they're more active, at least towards us, more knowledgeable, or at least in our contacts, more knowledgeable engineers representing them.
Okay.
So.
Yeah, with us it was basically medium-sized ISP, like very local ISPs and service providers with a very well-educated, with very well-educated network operators, such as research networks as well and stuff like that. So, but that might also be due to the fact that the huge networks don't come to our roundtables. So that might be the reason for that.
Yes, thank you.
Hello, David Farmer, University of Minnesota. I liked the idea of the deploying the separate route servers, because I hadn't been thinking of, hey, maybe the way to move this forward is just deploy side services. And so it's actually gotten me thinking about, well, what in my network, maybe I just deploy a VRF for validated traffic, and that creates this little side thing that I can use that if it goes away or breaks, it's not the end of the world. And so I think that's maybe the next step for this is deploying it in little pockets, side pockets to start with, and then get some experience and hey, if you deployed everything, if you can get everything rolled onto the side service and all of a sudden everybody's running it and all the real traffic is on the side service, well then maybe that becomes your primary service.
Please.
Hi, Joe Nelson from Google. I had a question for the router vendors and implementation. So I was wondering what happens when the router can't talk to the RPKI server? Does it fail open, or is that just policy specific?
The RPKI router protocol has one of the parameters in there. Sorry, it's a while since I've read the protocol, but one of the parameters is basically, if you're familiar with graceful restart, it looks a little bit like that. It's like, how long are you going to retain records before you age them out? And I think the default value is pretty high. So basically the robustness story is two things. One is that you make sure that parameter is set, order of like an hour or something like that. And the second is you deploy multiple servers. So you've got sort of the normal redundancy story.
John, can I follow-up for that. So I believe you said that you also supported a result or a state that was the equivalent of unverified, maybe was the term. And can you write policy about what you want to do with unverified?
Sure, yeah. You can
Does
test
that
it. You can
does that
test
address
against
this
that.
scenario also? You could write policy?
I'm not sure what I would do with that as a router operator. But people are, always showing their creativity. So I'm not going to say no, but I will say that I'm not sure how you use it.
Hi, Jonathan Stewart, Les.net, Manitoba Internet Exchange. The peers who are using the RPKI validating route servers, are they still peered with the original non-RPKI servers?
I don't know the exact number, but I think almost 100% do. Yeah. So they peer both.
Because the new route servers don't have very many routes, right?
Exactly. Yeah.
Right.
Yeah.
Okay.
Hi, Jay Borkenhagen from AT&T. Hank, when you were talking about your research into the cases where the routes were invalid, how they weren't really hijacks, they were just people, negligence, I think was the word you used. And I had a similar experience. A customer of ours was announcing a lot of invalid routes, mostly because they had registered or produced ROA for their own prefix. They went ahead and assigned more specifics to their customers. Those customers announced them through BGP, and those are invalid. I told this customer, there's a chance we could start dropping invalid routes. And they said, well, these shouldn't be invalid. Right? We have ROAs published. Well, I had to explain how the semantics were. And then their next response was, well, please don't drop invalids for a while because we got to figure this thing out. I mean, is there anything else to do other than just try to educate people that there is a different set of semantics than what you might be used to through normal BGP routing? The max length on a ROA doesn't exactly mean the same thing that it does on a BGP route announcement. You're going to have to publish ROAs for those more specifics if you want them to be valid. I mean, I think the biggest thing that I can see is there needs to be more education as to how these things are interpreted and what makes it invalid.
Yeah, I think you're right. Education is very key here. And of course, the ultimate thing you can do is not accept the invalid routes.
Yeah, they'd learn quick.
Then it should solve itself in a while.
Thank you.
I'll say, from what we always hear from customers and salespeople of customers is, for instance, with IRR stuff, which is, kinky to still a lot of people. I mean, not casting aspersions, but, enterprise folks, BGP is like, if they do BGP, it's like less than 5% of their job, and they really, can't be bothered with all this interdomain stuff. It's just, where it's our bread and butter for them, it's a small thing. And so then they're like, well, we're paying you, just make it, work for us, and we don't want to hear about it. So, it's a challenge, yeah.
I did want to say one more thing. Rick, you mentioned something about having a system involved for management of your RPKI stuff. There was a lightning talk, I think 2 NANOGs ago, by Chris Morrow of Google about his management architecture for RPKI. And it's another open source GitHub kind of thing. I think everybody here is doing that.
Okay, I want to thank all our speakers today, and especially the moderators. I know they worked very hard to put all this information together. And for the last 2 hours, I think I learned a lot about RPKI. Thank you very much. And just a reminder, please fill out a survey. And every day, there's a drawing for the participants, the survey participants. And it usually it's pretty awesome gift. So if you want to have a chance to win the drawing, please fill out the survey. And that conclude the event of today, but then we still have the social, peering personal social will start at 5:30 at the International Ballroom. So 5:30 International Ballroom, peering socials, okay? Thank you.